Okay, so let's continue with our statistics unit. I know that many of you don't have a GDC, so we're not going to do some work in the GDC, but we can still talk about the unit. The next thing we're going to talk about is continuous data. And so with discrete, it was countable. With continuous, it's measurable, like age, distance. And so, let's see, continuous data, it's that must be measured. I mean, literally measured, like you have to like get a ruler or you have to weigh it. And the idea, the difference is discrete is that your result is really not your result. Like, no, you didn't run exactly 5 miles. You ran like 5.000123, like something like that. Or for example, your age. No one's 15 like on the dot. Like you're 15 and you're somewhere between 15 and 16. And so that's how we're going to describe the data and the continuous data as like intervals of data. So it's going to be organized in intervals of equal width. So, for example, let's talk about the ages of students in high school. And so the idea is, yes, everyone's either 14, 15, 16, or 17, but that's not, I want a better representation of 14 years old. So I'm going to write 14. So over here on the column of age, I'm going to write 14 to, right, less than, but not equal to 15. So let's say your birthday is like August 15th. So you are 14 years old, August 14th at like 11:59, 11:59, 30 seconds, 59 seconds. You're 14 until that moment. So I want to include every single 14-year-old. And then same idea, 15, all the way up to, but not including the moment you turn 16, you're 16. 16, all the way, but not including 17, and maybe like there's some 17 years old, all the way up to 18. And that's the idea. So with continuous, it's every single thing within this interval. You might decide to cut it off half years. For example, everyone from January to June 30th, and then July 1st to December 31st. That's your call, but everything has to be equal. And so we have the age now. Now let's do the frequency. So we have the frequency. We discover that there's 30 kids who are between 14 and up to 15, but not including 32, 15 years old. We have 38 kids who are between 16, who are 16, and we have 36 kids who are 17 years old. And so the question is, how do we represent this yesterday? Well, yesterday in the discrete, we used a bar chart. So with the discrete, we used a bar chart, right? And the idea was that, we had the bars, they were equal. We represented them with equal length, but they were separate because there's no, this is like 1, 2, 3. There's no like 2.5. Yesterday it was like, how many things do you have? How many students came to school yesterday? How many times did you ride the bus? Well, there's no like 2.5. It's 1, 2, or 3. With continuous, we're going to use a histogram. What is it called? It's called a frequency histogram. And the idea is that there's no spaces. And so it looks something like this. I mean, I really should be using a ruler. The idea is, so let's start down here. We have 30, 32, so let's do 30, 32, 34, 36, 38. And over here, this is going to be 14, 15, 16, 17, and 18. And the idea is that this range is going to be represented by a rectangle. So this is up to 30. 15 to 16, up to 32. 16 to 17, this is really sloppy, sorry. This is 16, this is 17, this is 18. What's going on between 16 and 17? There's 38 kids. And what's going on between 17 and 18? There's 36 kids. We see here, there's no spaces. There's nothing between like 14 and 15. Either like you're 14 and then you're 15. You're either 16 and then you're 17. There's no like, I rode the bus once or I rode it twice. So there's no spaces. There's no spaces. Good. So once again, please remember that. Discrete bar chart, continuous frequency histogram. Okay, so let's take a problem out of the book. The next thing you want to be concerned with, although you really don't have to worry about it, is just how do you determine the intervals? Right, so, like figuring out the intervals. Let me erase this, sorry. So let's put some data on the board. We have 4.9, we have 5.8, 7.2, 6.7, 3.8, I have 4.6, 6.0, I have 5.0, 3.7, 7.3, 6.0, I have 5.4, let's see, 4.2, 6.6, 4.7, I have 5.8, I have 4.4, I have 3.6, 4.2, and 5.9. And the question is, how do I organize this data? Well, how do I organize these numbers? Do I give them all individual numbers? Well, I'm not doing that. So the question is, the first thing you're going to do is first find the min and the max. So the minimum is obviously the smallest number, and I'm looking through here and I'm like, okay, there's a 3, 3.7, it looks like 3.6 is the smallest. And what's the max? Well, we're out here. Well, I have a, let's see. Oh, here's how much 7, so 7.2, 7.3. Yeah, I think 7.3. Let me check my notes. 7.3. So what I'm going to do is, first of all, how many data points are there? Let's see. 1, 2, 3, 4, 5. Let's see. 3. 1, 2, 3, 4, 5, 6, 18, 19, 20. There's 20 values. So you know what I'm going to do? I'm going to make my interval. How many organize this? Let's see. Let's go to 3.0 up to 4.0, but not including it. Let's do 4.0 up to, but not including 5.0. We're going to do 5.0 up to, but not including 6.0. And then we're going to do 6.0 up to 7.0, but not including. And then last we have 7 up to, but not including 8.0. You know, you can choose to break it up even further, but you know what? What is my eraser? Oh, here it is. This is good enough, and then maybe you count it up, or in this day and age, the computer will do it for you. So let's say, 1, 2, 3. So there's 3. Between 4 and 5, 1, 2, 3, 4, 5, 6. between 5 and 6, 1, 2, 3, 4, 5. Let's see, between 6 and 7, 1, 2. This is part of 6 because it's 6.0. Let's see, 1, 2, 3, 4. And then the last one, what do we have left? Well, we have a couple of ways. Let's see, 9, 13, 18. There should be 2. Let's see, 1, 2. We know the sum is 20. We're good to go. So it's your call. So once again, it's a little old school, but this is how we organize continuous data. We're certainly not going to get every single one of these their own individual lines. So we're going to do continuous. We're going to break it up into intervals and then tally it up. You might ask, how do we know exactly what's in each of these? We don't, but that's something we're going to talk about a little bit later. Last thing, we're going to talk about modal class. Modal class. What do you think that is? Any suggestions? Well, you know the mode is the data that occurs more than the others, but you learn it as the most. Well, the modal class is the interval with the maximum frequency. And so in this problem, 4 to 5, this will be your modal class. Once again, we don't know, if you just look at this chart, I don't know anything about what's inside. The only thing I know is that the most data occurs between 4 and 5. Good.